So you were supposed to watch the Edpuzzle that kind of gave you an intro to domain and range. We're going to talk a little bit about it today. And then tonight's homework is going to be in the Nearpod. And it's matching the graph to the correct domain and range. And then it has to be correct in order for you to move on. So you can keep doing it until you get 100%. So you need to do that. And there's like 2 different matching portions. So nothing you have to write down. You just get to go in and do a matching game for the domain and range. And then it'll automatically submit to me when you are done. So definitions. Domain. The domain are the X values. Okay, they're also known as the input values or the independent variable. The independent variable is the one you're plugging in. The dependent variable is the one that comes out. And it's dependent because it depends on what you plugged in, what you get out. The range are the Y values and are known as the output or the dependent variable. Now this is one of the lessons where we use different colors a lot, so I need you to have 2 different colors of highlighter or pen, okay, to mark up the graph. I'm going to use red for domain and I'm going to use green for range, okay? So if you want to use the same colors as me, I'm going to use red for domain and green for range. So the domain are the X values. So when we're looking at a graph, we're looking for what X values the function or the graph takes up. And so for this graph, which is called discrete because it is just 4 separate points that are not connected, my domain is, I'm going to put a little line on every point. Would you agree that those are the values? I'm going to just make this bigger for us. Those are the X values. So to write our domain, we use set notation. So curly brace, X, vertical line such that, and then in this case it's just a list of numbers. X equals -3, 1, 2, and 3. And we generally write them from smallest to largest. And then our range are the Y values. The Y values that the graph uses up. And then we also use set notation, Y, such that Y equals -4, 1, 3, and 6. So when it's discrete points, it's just a list of the X and Y values. It's like taking each ordered pair and separating the points from it. So the second graph is really similar, so I'm going to have you do that one on your own, and then we'll see what you get. So go ahead and write the domain, draw on your graph, write your domain. So for this one, for x, I have -3, -2, -1, 0, 1, 2, and 3. Why can I not write that as an inequality? Anybody know why I can't write that as like from -3 to +3? When I write an inequality like this, does 1.5 count? Yeah. Is 1.5 one of these points? No. So we can't write that as an inequality between statement because we're not using every number in between -3 and 3. We're only using the integers. So we'll write it as a list. And you might see it like this in some of our solutions, because before we had talked about x is contained in z. Okay, before we used to do a lesson on the number sets, and z, just like the double-lined r is all real numbers, z is the integers. So if we wrote the inequality and said it's included in the integer set, then that would work because that's only -3, -2, -1, 0, 1, 2, and 3. If it's contained in all real numbers, then it's isn't it? Oh, you're right. I'm sorry. I saw an extra point out here, didn't I? So this should be, and this would be 2. You do not have to write it like this. You do not have to really understand that. But if you see this in the solutions, know that this is okay to just list them out. Okay. What is my range? From 1, 3, 4, 5, and 6. So y equals 1, 2, 3, 4, 5, and 6. Okay. So that was my domain and range for discrete points. And they're just a list of numbers. So let's look at the third one. Now the third one is connected, but it's not a line because it stops on each end, right? Think back to geometry. What's the word for that? A segment, right? So this segment goes from here to here. So I brought my point down, this point on the x-axis and this point on the x-axis and everything in between, and closed circles here because I have closed circles. So I'm going to use or equal to sign, right? So I have my domain x such that this is -2, and we want to write it as a between statement. -2 less than or equal to x less than or equal to 3. Because it's continuous, I can just write the interval. And my range goes from here to here. So from 2 to 7. Such that 2 is less than or equal to y less than or equal to 7. Okay, so we want to use between statements for segments. Okay, questions? So here's number 4 and 5. Now these start on one end and go continuously in one direction. Remember that vocabulary word from geometry? It's a ray. So this starts here and goes in this direction infinitely. Is this direction less than or greater than to the left? Less than? I feel like Dora the Explorer. I'm asking questions and waiting for an answer, and then I'm answering myself. Thanks. Okay, then less than or equal to, because it's a closed circle, so less than or equal to 2. And then up, this graph starts at positive 2 and goes up the y values. So y such that, again, up is greater than, y is greater than or equal to, because it's a closed circle, positive 2. Can you write the next one? Number 5. Do we have answers yet, or are we still working? You can only actually see 3 faces, and they kind of look like they're done. So let's do this one together. So this the domain is from here up. Those are the x values. And that's -4. So x such that x is greater than or equal to -4. Greater than or equal to, because it's a solid dot. And then the range, it goes down. So y is such that y is less than or equal to 4 as well, +4. Okay, so you can see how drawing on the graph just kind of helps us to visualize what the x values are. And that's why we like to show it to you this way and have you do that along with us. Now you won't be able to draw on the graphs on the homework, so hopefully you'll be able to like visualize that. Okay. All right, let's look at number 6. So for 6, We can see that my x's start here and go greater than. There aren't any x values over here. So this is x such that x is greater than or equal to positive 2. Now my y values are going up and down. It keeps going this way. And it keeps going this way. What did we say is the answer if the whole number line is shaded? Yes, all real numbers. So y such that y is contained in the set of all real numbers. That's the bottom of this page, correct? All right, so that's how we find domain and range. Now we're going to talk about whether a relation is a function. A relation is a set of ordered pairs. A function is a special relation that has exactly one input and exactly one output. So every time we put in one number, we get the exact same number out every time. We can't have a relation where we plug in 5 and sometimes we get a 2 and sometimes we get a 3. That would not be a function. So we'll look at the vertical line test once we get down to the graphs. Which of these relations are functions? Well, what we want to look at is the inputs. My inputs are 6, -4, 9, and -4, the x values. And we'll look at our outputs. Because we have a repeating input, now I want to look at the output. If the output's different, then it's not a function. So here we have 0 with the -4, and then here we also have an output of 7. So here, this one is not a function because we have one input with two different outputs. With number 2, when we look at our inputs, 7, -3, 9, -4, there's no repeating outputs or inputs, so we have a function. Number 3, we have inputs of 3, 5, -3, -8, 5, and 13. So here we want to look at the 5. Okay, we have the same output. So even though it's listed twice, it's still the same output for that input of 5. So this is a function. Looking at number 4, inputs are -1, 2, 2, and -4. Do you think this is a function? No, this is not a function because we have two separate outputs. So this is not a function. Now, because the input is the x-axis, we can use the vertical line test to determine if a graph is a function or not. The vertical line test says if a vertical line touches the graph more than once, the graph is not a function. So I'm going to draw a vertical line here. On number 5, there's a vertical line, touches once. The minute I move over, I have a vertical line that touches twice. I have two outputs for the input of +2. So this one is not a function. If I draw vertical lines across the graph for 6, this parabola, doesn't matter where I go, and remember I'm not talking about the coordinate plane, I'm just talking about the parabola. No matter where I draw that vertical line, it only touches the parabola once, so this one is a function. Looking at 7, draw some vertical lines, touches 1 point, touches 1 point, touches 2 points. It's only allowed to touch once, so this one is not a function. Can you look at number 8? What do you think that is? If I draw a bunch of vertical lines, will I touch the line more than once? No. So this is yes, it is a function. Now I want to stop and take a second and look at the domain and range for this function, because when we have a line, it's continuing in this direction and that direction. Here we have a domain and range of all real numbers. So whenever we have a line, not a horizontal line, not a vertical line, but a line that has a slope other than 0, we have all real numbers for both domain and range. And so let's look at number 9, vertical lines, only touching the graph once, no matter where I go. So yes, this is a function as well. And then lastly, number 10, if I draw a vertical line through each of the points, I'm only touching 1 point at a time. So yes, this is also a function.